intro to trig identities. Like I said, we're going to just practice with adding, subtracting, multiplying, and dividing fractions. The first one we're going to look at, wait guys, put your phones away please. Number 1 is n plus 2 over 10n cubed plus 10n squared times 8n cubed plus 8n squared over n plus 2. Now before I start, let me ask you a question. If I told you 1/2 times 2/3, how do we multiply fractions? Right. No, multiply. Multiply, you just go straight across. 2 and 6, and then you reduce it as possible. Or the other option is you can simplify first, right? And the rule for simplifying fractions is as long as one's on top and one's on bottom. So I could simplify the 2's, and then it's still the same. You're multiplying, so you go straight across. 1 times 1 is 1, and 1 times 3 is 3. Correct? Just multiply fractions like always. Okay? So you go straight across when you multiply fractions. With this, it looks like one giant, messy, confusing, scary fraction, right? So what we're going to do is take a look at each piece and factor it. In other words, make it look a little simpler, a little prettier. The n plus 2 you can do nothing with. Okay? What can I take out of here? What can I take out of here? What common? I've got a 10 and a 10. They both have 10s. Right, and I've got an n cubed and n squared. So the highest, you take out the lowest power, right? Which is n squared. Good. So neatly draw a line through here and write what we decided to take out. A 10, an n, and a 2. And then you're going to write what's left over. Now, for those of you that don't naturally see it, what you're technically doing is you're taking this 10n cubed. You don't have to write this down every time. And you're dividing by 10n squared. Right, and taking it out. So that would cancel. And then n cubed and n squared gives me how many n's? 1. And some of you may be able to just see it. If I take a 10n squared, that's going to be gone, and it's going to leave me with an n. Now go to the next one. Okay, here, the 10's are going to cancel, and the n squareds are going to cancel. They're exactly the same, so what do you put there?
N plus 1.
A plus 1. Excellent. Now go to the top up here. Let's try this one. You draw a real nice, clean line through it and factor it. What can I take out? I've got an 8 and an 8. So I can take out an 8. Can I take out anything else? A cubed n and a squared n. What's the biggest n I can take out of both? N squared, which I should have written that first. Sorry. So I can take out an n squared also. So the 8's are going to cancel. If I'm dividing this by n squared, how many n's do I have left over? 1. And this is exactly the same, so what am I going to write? Plus 1. Got it? Okay. Now remember the rule. When you're simplifying fractions and multiplying, as long as one's on top and one's on bottom, you can cancel. So let's start canceling. I can cancel the n plus 2 with this one. Does anybody else see anything that's exactly the same? Yep, the n plus 1's go away. And now it's looking pretty messy, right? So you don't want to mess it up and forget anything. So what do I have left on top? Let's clean it up a tiny bit. Right, an 8n squared. This is the only thing that's left up here. What's left in the bottom? Okay. Now then you've got it all nice and pretty. Can I reduce it any farther? Yeah. The n squareds cancel. They cancel completely, right? Okay. And my 8 and my 10 can both be reduced by 2. So these go away. You're dividing basically now both by 2, and you get 4/5. Good. So all that gigantic mess turned into 4/5. It's going to happen a lot.
So if they could have just taken away the n plus 2,
it's all the same. It all cancel in whatever order you chose to do it in. Yeah. I did that. I canceled them. And you could have done that first, but it's all the same. Okay, let's go to the next one, number 2. A minus 6 divided by a minus 2 times 10a minus 90 over a squared minus 15a plus 54. factor something, right? But so let's just start, okay? Can I take care of the a minus 6? No. Can I do anything to a minus 2? No. Look at this numerator here. Can anything come out of a 10 and a 90? What can I take out of here? Good, I can, so draw a neat line. I can factor out a 10. So 10a divided by 10 leaves me with a, and 90 divided by 10 leaves me with none. Okay, the next part, like I said, it may have been a while. Do y'all remember the little trick on factoring a trinomial? You want numbers that are going to add to give you the middle term and multiply to give you this last term. I always call it the AM, like the morning, right? AM. That might help you. So when you see 3, okay, what you should do first is set up a set of binomials. What do you think the first term of each is going to be? You have A, right? So it's going to be an A and an A. Now I'm looking for numbers that multiply to give me 54 and add to give me 15.
Maybe 6 and maybe 9.
Okay, well, you can start listing. 1 and 54 is not going to make 15, is it? Okay, and you can keep going. What would you say, 9 and 6? 9 times 6 is 54. Does it give us 15 also? 9 plus 6 is 15 too, right? So then let's just make them both 9 and 6.
They're both negative.
And they're both negative. Excellent. So minus 9, minus 6. Okay, oh, I forgot my little. Draw your neat line because now that's gone. Okay, let's cancel what we want. It's on top, you can cancel. It's on bottom, you can cancel. It doesn't matter if they're diagonal or top and bottom. So here's a minus 6 is gone. A minus 9 is gone. What's all that's left on top? Be real careful. Follow it all the way through. What's left? Just a 10. What's left on bottom? A minus 2. Now, some kids try to do this. Look up here so you don't make this mistake. They try to make this a 1 and a 5. In fact, you do now. Do not do that. In order to simplify, it has to be simplified with all 3 terms. It has to fit into everything. So you leave it just like it is. It's just 10 over a minus 2. It's just this. Number 3. X squared plus 4x minus 5 over x plus 5 times 5x squared over x minus 1. These problems start out nice and pretty, but they end really messy. Start at the top. Can I factor this? It's a trinomial, right? So the first thing you're going to do is set up your sets. See if you can factor it. It starts with an x squared, so you're going to put an x and an x. Okay. Usual AM trick. Add to give you 4 and multiply to give you 5. There's only one way to get 5.
-1.
Right. 1 and 5. So put your 1 and 5 here and work on your signs. You want a positive 4, so the heavy one needs to be positive. The other one's negative. Now let's cancel. Okay, am I allowed to cancel these right here? This x plus 5 here and the x plus 5 here. Yeah, they don't have to be diagonal. Most of the time they will be diagonal. They don't have to be. The rule is 1 on top, 1 on bottom. Where it's at doesn't matter. Okay? So cancel the x plus 5s, cancel the x minus 1s, and what's your final answer actually? Is it right, it's 5x squared. And you can put 5x squared over 1 if you would like, but it's the same as 5x squared. If you have something left in the denominator, the 1 has to stay. Okay? If you have something left in the denominator, for example, it would be 3. You have to put the 1 there, 1/3. You can't just put a 3. Right? If you have nothing left in the denominator, yes, that's okay. You can just write 3. Okay, so in other words, if you have nothing left in the denominator, you can just write the top answer. Alright, let's move to number 4. K plus 5 over 2k squared divided by 12k squared plus 18k over 4k cubed plus 6k squared. Good job. Immediately, what do you guys see? What kind of problem is this? It's not a multiplication problem, it's a division. Okay, you need to personally decide on how you want to do this, but do not wait to flip. You can either rewrite the whole answer, okay, or you can just kind of cross this off, okay, change it to multiplication and flip it. But do not wait. Because you know what's going to happen, and I see it so many times, kids forget, like, oh yeah, I'll flip it when I'm done. And they forget. Okay, flip it right away. First things first. So a lot of work to be doing and then mess up on. But when you mark this off, be sure you do a good job. You don't want to get confused. Alright, now then let's factor. Can I change anything on the first one? First one's easy, isn't it? Can I do anything to either? No. Excellent. What can I take out of here? 4 and 6. What can I take out? A 2. What about a k cubed and a k squared? Good. So take out, put a neat line through the top, and take out a 2k squared. The neater you are with this, the easier it will be, and the more accurate you'll get it. Those of you that tend to be a little bit messy, try to clean it up for this unit especially. It's hard for me to give the tests. These are more like proofs later, and I can't give you partial credit if you don't show me your work. So this will be k plus what? Yes, thank you. 2k plus 3. Now factor the bottom. What can I take out of a 12 and an 18? 6 and a k, giving me 2k plus 3. They usually will. You know, you did something wrong. There's something's looking kind of weird. Alright, cancel very neatly and carefully. I'm going to take out this 2k plus 3 and this one. Do you see anything else that cancels? Yep, the 2k squareds. Giving me a k plus 5 on top. Make sure that's it. Check. Everything. Check on the bottom. Done and done. So all we have is 6k. Can those k's cancel? No, they have to cancel with all 3. Bam, bam, bam. Everything had a k, yes. They don't, so you're done. Number 5. M squared minus 6m minus 7 over m plus 1 divided by 1 over m minus 4. First things first, I'm going to turn this to multiplication and I'm going to cross this out and flip it. I don't want to make a mistake. Now factor. Draw a neat line through this. There's only one way to get 7, right? Remember the AM trick? Add to give you 6, multiply to give you 7. There's only one way. How do you get 7? It's prime. 7 and 1. Which one's positive?
1.
Wait a minute. I want negative 6. So which one needs to be positive? Right. Negative 7, positive 1. Cancel what you can. Okay, now this is weird. I was left with stuff on top and nothing on bottom. That's fine. Write down what you're left with. n minus 7 on top, and an n minus 4 on top, and what's left on bottom? This. I knew it was coming. Alright, so the final answer then, sorry about the fire drill, guys, was m minus 7 times m minus 4. And on the bottom, there's only a 1 left. Remember, when there's only a 1 left in the denominator, you don't have to put it. Foil it? No, they're already factored, so you're good. She's asking you to foil it back. No, you do not. Good question. So now then we're going to move to 1 over n plus 3 divided by n minus 1. We have n squared minus 5n minus 24. Again, it's division. You've got to look for division. So we're going to change division to multiplication. I'm going to cross this out and flip it. Be sure you cross it out real well because you don't want to accidentally try to cancel stuff with it. You know what I mean? Now let's factor the numerator. To factor, I'm going to cross a nice line through it. It's going to lead with an n. I want numbers that are going to add to give me 5 and multiply to give me 24. Okay, you can list factors of 24 if you want. 1 and 24, 2 and 12, and then now you're at 3 and 8. One that works. Yeah, you got to watch your signs now. I want to hit negative 5, so I need negative 8 and positive 3. Very good. Right. These cancel. Now look very carefully. Very careful on the top. You have a 1 and an n minus 8. So you're n minus 8 on top. And then nothing on bottom except your n minus 1. Do the n's cancel? No. Do not try to cancel those n's. The n's do not cancel. Now we're going to switch gears. How come they don't? Has to do with everything. The same thing I've said every single time. Look.
Alright, gotcha.
Do you see what I'm saying? At
Yeah.
the end, we have to do everything for it to cancel. Alright, let's move to, we're going to switch gears. Thanks. So we've done multiplication and division, so now we're going to move to add and subtract. Let me talk to you really quick about it. But you're going to take 1/2 plus 1/3, for example. What do you have to have in order to add a fraction? Common denominator. Okay, and there's 2 ways to look at this. Please pay attention to this so you can make the connection in just a minute. So my common denominator, you can rewrite both of them if you would like. What would it be? 2 and a 3 make 6. So you would put a 6 for both. Okay, in order to get from 2 to 6, we multiply by 3. So you're going to multiply the 1 by 3. That's how you land with the 3 here, correct? Remember? Pay attention. Now here, 3 times 2 gives me 6, so 1 times 2 is going to give me 2. So then the answer is 5, 6. That's the way we've normally done it. Now these problems, the denominators are so long, they're not like just one little bitty number, that we're only going to write it once. Okay, so instead, same exact problem, okay, 1/2 plus 1/3, but we're going to do it a little bit different. Okay, what did we say our denominator was? A 2 times a 3 is a 6. So our denominator is still 6, right? Okay, so we only write it once. And then in order to, we just glance. To get from 2 to a 6, what did I need? A 3. So I'm going to multiply this by 3. 3 times 1 and I drop down by 3. Now I move, pay attention, some of you are not listening. Now to move to this side, a 3 to a 6 needs a how much? A 2. So 2 times 1 is 2. So 3 plus 2 is 5, 6. Still the same answer. It's just that we're only going to write the denominator one time because it's much easier, right? Because these denominators today are going to be really long. Let's try the first one. Remember 7? You're going to have 6p minus 5p over 6p plus 6. This is an addition and subtraction problem. We're switching gears. So you need a common denominator. Now, first thing is I would take the subtraction, I would turn it to a plus, and I would move it over. Because if you accidentally forget that 5p is negative, it'll throw you off. Now then, I'm going to put this over what? To keep it simple. So we'll have two fractions. Put it over 1. Okay? Now then, let's compare. If I have a 1 and a 6p plus 6, what's my common denominator going to be? Yeah, 6p plus 6. Now, you're going to compare. This matches this, correct? What does it need? It needs all of it, doesn't it? Okay, this side needs nothing. They match perfectly, so I can just drop down my 5p. But these don't match, do they? So in order to make this side look like this, you're gonna multiply by 6p plus 6. So 6p times 6p is 36p squared, and 6p times 6 is just 36p. And then what do you now go to the next fraction? These match, right? So what are you going to do with this one? Drop it down. This one matches, so just drop it down. Okay, can I clean up the top at all? Is there anything I can put together? These match. Yep, they are like terms. So you end up with 36p squared plus 31p over 6p plus 6. Right?
Yeah.
And originally the problem was this, and I changed it. I went ahead and changed it at the beginning so we didn't forget. Because otherwise kids drop down to plus 5p not remembering it was subtraction. Okay, guys, just look. Don't actually write anything down. Okay, let me show you something. You would need to check this. For example, I can factor this, and then you can also factor p out of here. But did it help any? Can I cancel anything? No. So if it doesn't help, just erase what you factored, okay, and box the answer. Alright, the next one. 5 over x minus 6 minus x minus 6 over x minus 2. What's the first thing to do when you see a subtraction problem? What are we going to do first? Okay, flip division. What do you do when you see a subtraction? You want to be careful. You want the first fraction minus the second, correct? So you distribute the negative. Now, do I distribute the negative through the top and the bottom, or just the top, or just the bottom? What do I distribute it through? Yeah, just the top, and here's the reason. Look, I'll put it up here so you can see. If I have a negative 1/3, I can either write negative 1 over 3, but I can't put negative 1 over negative 3 because then it turns positive. Right? You're only allowed to distribute to the top or the bottom. So go ahead and take care of that. I'm going to make this positive, which changes this and this. Look at your paper and be sure you change everything. You distribute the negative through all the numerator. Now then, get your common denominator. What's your common denominator here, guys? You need one of both. You need this and this. Right, so put your divisor here and put one of both there. X minus 6 and an x minus 2. Now let's compare. This has an x minus 6, so what does this first fraction need? It needs the x minus 2. So you write down 5x minus 10, correct? Go to the next one. It has the x minus 2. What does it need? It has this. It needs the x minus 6. Now FOIL it. Be careful because it's binomial times binomial. So negative x times x is negative x squared. Negative x times negative 6 is positive 6x. And you have to go this way, 6x and negative 36. Let's clean up the top. Negative x squared. Put all my x's together, giving you 17x. And put your 10 and your 36 together, giving you negative 46. All over your x minus 6 times your x minus 2. Yeah, leave it. Yeah, you always want to leave it like factored because you're looking to see that something will cancel. You know what I mean?
Yeah.
And then you can try to simplify this, but nothing works. Like 1 and 46 is not going to make 17. 2 and 23 does not make 17. It doesn't factor. That's just your answer. Number 9. 6x over 2 plus 4 over 2x plus 1. Now guys, this one's easier because it's a plus. It's the minus you have to remember to distribute. I'll give you a second to try it. Did you get the common denominator? What would it be? You need both. So what would I write?
4x plus 2.
Okay, do me a favor and leave them separate because it makes it a lot easier. Okay, because maybe they'll cancel, right? So we're going to leave it as 2 times 2x plus 1. That will make the problem a lot easier. Right, we're trying to simplify stuff, not multiply it out, right? Now then, let's compare. This first fraction has a 2, so what does it need? Excellent, 2x plus 1. So you're going to take 6x times 2x to give you 12x squared, and 6x times 1 to give you 6x. Now you try the second fraction. What does it need, and what would you put on it? What's it need, guys?
3.
Good. Look, these match. Right? It needs a 2. It's got a 2 on the bottom. It needs a 2 on the top. That gives you 8. Okay, can I take a GCF out of the top? Can I factor it at all? What comes out of there real nice and clean?
2.
Good, a 2, giving me 6x squared plus 3x plus 4. And on the bottom, 2 times 2x plus 1. See why we didn't want to FOIL it? Because what cancels now?
2.
The 2's. You don't want to put them together. You're trying to break it down, factor as much as possible. Okay, and that's it for today.